Hello SGD, Sacred Geometry Decoded. I'm going to add this to the playlist, but I won't call it one of the parts of this, but because I'm going to explore it more. This is going to be a bit ramshackle design. But so what we have is connecting all of these pyramids, the Egyptian raw cube, but of course, and other geometry. But there's a very interesting series of connections, and it has to do with the Fibonacci numbers and the Lucas numbers, and they're all nicely joined in here. Now, okay, so you might have seen this spiral. This is a spiral based on the Fibonacci numbers. 1 plus 1 is 2, then 1 plus 2 is 3, 2 plus 3 is 5, 5 plus 3 is 8, etc., etc. Now, just as lovely, very important, is called the Lucas numbers, and these are over here. So this particular spiral is at a 7 to 11 ratio, but Lucas numbers begin 1 and 3. So 1 plus 3 is 4, 3 plus 4 is 7, 4 plus 7 is 11, etc. Now, both of these come back to the golden number, Phi. So different symbols for it, but Phi equals 1.618033988, etc., etc. What makes Phi so beautiful is that Phi plus 1 equals Phi squared. That's just one of the beauties of it. Only this number. This is unique. So this is why you see it in pine cones, shells, sunflowers, galaxies, hurricanes, etc. Now, 1 divided by Phi equals Phi minus 1. So Phi plus 1 equals Phi squared. 1 divided by Phi equals Phi minus 1. Phi squared equals Phi plus 1. It's truly, it mathematically, geometrically, in nature, it is just beautiful. It's essential. It literally is found all throughout nature. Some examples of that is shells. Not all, but certain shells, because there's a different. It's not just a Fibonacci. It's not just a Lucas. Phi is built. It's just nature insists on it. This would be some aspects, whether it's spiral galaxies, hurricanes, golden angle, which defines. So the angle between each one of these leaves as it expands out is at the golden number. They call it the golden angle. And you'll also find, especially Fibonacci numbers, which is one expression of Phi in sunflowers. So that's just some aspects of why it's so important in nature. Now here we have the Fibonacci numbers, 1, 1, 2, 3. Now, the further and further you go down, the closer and closer it gets to perfect Phi. Never actually reaches it. You can do it geometrically, but as to like the 100,000th decimal place, you would be able to calculate it. But so if I divide this Fibonacci 89 by the one previous, so 89 divided by 55 is 1.61818, and it gets better and better. But just as an example, so 1 Fibonacci divided by the previous equals to Phi. Now if I skip one, for instance go to 144 divided by 55, I get Phi plus 1, or Phi squared. If I skip the third and go from 233 divided by 55, I get Phi cubed. 377 divided by 55, I get Phi to the fourth, and this will come in, and etc., etc. So at first, second, third, fourth, fifth dimension onto infinity. And these are rounded off because I'm working at the lower aspects of the Fibonacci. If you spreadsheet it, go up further and have better calculator, it'll come even closer. Now, one of the best ways to describe Phi is the square root of 5 plus 1 divided by 2 is Phi. Phi minus 1 is equal to Phi minus 1 is equal to 1 divided by Phi, and square root of 5 minus 1 divided by 2. So there we see square root of 5 plus 1 divided by 2 is Phi. Phi minus 1 is equal to 1 divided by Phi is square root of 5 minus 1 divided by 2. Phi squared is square root of 5 plus 3 divided by 2. Another way to get the square root of 5 plus 2, square root of 5 plus 2 is equal to Phi cubed. Okay, so just sort of laying. But what we have is in the Egyptian pyramids, they're all linked. The Fibonacci numbers, yes, okay, now in regards to the square root of Phi, the Salamis stone, which it's a measuring tool which incorporates multiple ancient measures, and there's so much going on here. but at the base length, which would be 4 ionic feet, is 3.84 feet, which is the square root of 5 Egyptian raw cubits within 1/3 of a millimeter. And there are other, well, square root of 5, and now what I mean by that is if we go back to the Fibonacci numbers, 1, 1, 2, 3, okay, and then we have the Lucas numbers, 1, 3, 4, 7, 11. Now there's a very interesting link between the Lucas numbers and the Fibonacci numbers, and so we have the Lucas numbers 1, 3, 4, 7, so the first Lucas number, Phi, divided by 1 over Phi, which is equal to Phi minus 1 equals 1. Okay, now if you go to the next Lucas number 3, Phi squared plus 1 divided by Phi squared equals 3. Phi to the third minus 1 divided by Phi to the third equals 4. And it just repeats, minus, plus, and you just increase to the 5th power, to the 6th power, to the 7th power. So that will bring you to the Lucas numbers. But it's also interesting is if you have the Fibonacci sequence, 1, 1, 2, 3, 5. Okay, so if I skip the Fibonacci, so 1, skip the next one and go to 2, so 1 plus 2 equals 3. The next Fibonacci is 4, 1, skip, so 1 plus 3 equals 4, etc., etc. So the Lucas and the Fibonacci are linked. They're a special case. So let's go to a spreadsheet, and so Fibonacci numbers. Okay, I'm going to put Lucas numbers over here. Okay, so first Fibonacci 1, next one is 1. Just use an equation, so 1 plus the 1 above it equals 2. Therefore, we just stretch this down, and now we have the Fibonacci sequence. Now we can do the same with the Lucas 1 and 3. Okay, out of the equation, so the 1 above plus the 1 above that. Now we have the Lucas numbers. I'm sure someone has noticed this, but I just stumbled upon it today. I'm sure someone has. No, but so back to the importance of the square root of 5 in giving us phi ratios. So especially phi equals square root of 5 plus 1 divided by 2. Okay, so what goes on with the Fibonacci? So I'm just going to divide the Lucas number divided by the Fibonacci. So this number divided by the... Okay, now if we drag that down, it's going to get closer and closer to the square root of 5. I'll bring up a calculator. Okay, so square root of 5, 2.2360679. Well, 2.23606. So the square root of 5 is a relationship between the Lucas number and the Fibonacci as well. And so I'm just playing around with it. What would be the next one? So I'm going to skip one, and so the Lucas number, the second Lucas number divided by the first Fibonacci. What do we get? 3.61803399, etc. Now back to the calculator. Okay, so clear it. So let's just work out what phi is. So clear. So 5 square root of 5 plus 1 equals 3.23, and then we just divide that by 2, and now we have a golden number, 1.618033. Okay, that's phi. Now if we square phi, 2.6, so phi plus 1 equals phi squared. So those Fibonacci and Lucas numbers is phi squared plus 1 or phi plus 2 depending. Okay, so clear that. Now memory recall, I've already got phi in there, so I'm going to put phi to the 4th power, 6.85411101. Sorry, that's okay. So let's just insert a column. So instead of, I'm going to go to the third Fibonacci, sorry, the third Lucas number. So 4 divided by the third Lucas divided by the first Fibonacci. And if we stretch that down, we get closer and closer to 5.85410, etc. And, well, that is equal to phi to the fourth power minus 1. Minus 1, 5.84, sorry, 5.854, 5.854. Now, any number sequence, if you keep building it up like the Lucas or Fibonacci, will come to the Phi ratio, but this is the Phi Fibonacci and the Lucas numbers can be used basically as the underlying relationship between all of these pyramids, and I'll go into it more in the future, in coming up. I'll put some links in the description how you can draw Fibonacci, Lucas spirals, how they connect to the pyramids. In those videos I didn't, well, there's new information in regards to that, but yeah, Fibonacci and the Lucas numbers is which emerged from the Vesica. Drawing the Vesica is one of the best ways to begin either a Fibonacci or a Lucas spiral. Links to those videos will be in the description. I'm going to add this to the playlist, but what we have is math and measure and fundamental geometric proportions being embedded in these tools, conversion tools which convert multiple sets of apparently unconnected ancient measures, and architecture which are linked to geometric constants and mathematical constants. It's all there. It is, and it's actually quite a simple beginning point. The Vesica, Lucas numbers, Fibonacci numbers, pi, phi, and then the astronomical proportions, musical proportions, beautiful arithmetic, beautiful geometry really does emerge from it, and it can be done with very, very simple tools. Now, luckily, I have a spreadsheet. I don't have to spend hours and hours doing the arithmetic, but bang, here it is. I'll add this to the playlist. I'll explain a little bit better and show it with graphics, but this is what's going on, and it doesn't just join the pyramids. It joins stone circles, Karnak in France, all these temples around the Mediterranean and over to ancient India. And I've only explored Mesoamerica a little bit, but we have the same dimensions, similar angles, same geometry going on, and these are the laws of what nature insists upon us. All is number. Have a good one.